Hi students. Okay, today in this lecture we discussing the topic is some theorems of jet transform. The first one is first shifting theorem or shifting un to the right. See the statement here. So if jet transform of un is equal to f of z, then jet transform of un minus k is equal to z power minus k into f of z. అంటే k is a positive integer, అంటే k is equal 1 2 3 up to so on. అంటే now we have to finding in this one z transform of un minus 1, z transform of un minus 2 up to so on. Okay na? So to finding this value, first of all assumption un, na? So first finding z transform of un is equal f of z. So f of z is equal substituting here. Okay na? So this is the first shifting theorem. So note that is substituting k value positive integers. So that is equal to z transform of un minus 1 is equal to z power minus 1 into f of z. Z transform of un minus 2 is equal to z power minus 2 into f of z. And z transform of un minus 3 is equal to z power minus 3 f of z up to so on. So this is the values. First shifting theorem. So next one. So second shifting theorem. Shifting un to the left. See the statement here. Yeah, if z transform of un is equal to f of z, then z transform of un plus k is equal to z power k into f of z minus u naught minus u1 by z minus u2 by z square minus up to so on u k minus 1 by z power k minus 1, where k is a positive integer. And that means you have to finding here z transform of un plus 1, z transform of un plus 2, z transform of un plus 3 up to so on. Okay na? So అది ఫైండింగ్ n plus k కాబట్టి లాస్ట్ టర్మ్ ఏముంటుంది మనకి, ఓన్లీ వన్ టర్మ్ ఇస్ డిక్రీజింగ్, k కాబట్టి k minus 1. ఓకేనా? సో సిమిలర్లీ we write the separately. See the note here, substituting k value is a positive integer. So that is equal to here z transform of un plus 1 is equal to k is equal 1 కదా, అప్పుడు ఏమొస్తుంది z పవర్ 1 f of z మైనస్ u నాట్. సో 1 కాబట్టి బిఫోర్ టర్మ్ u నాట్. ఓకేనా? నెక్స్ట్ z ట్రాన్స్ఫార్మ్ ఆఫ్ un ప్లస్ 2 ఈజ్ ఈక్వల్ టు z స్క్వేర్, k ఈజ్ ఈక్వల్ టు కదా z స్క్వేర్ f ఆఫ్ z మైనస్ u నాట్ మైనస్ u1 బై z అప్ టు u1 వరకు. సో సిమిలర్లీ z ట్రాన్స్ఫార్మ్ ఆఫ్ un ప్లస్ 3 అప్ టు u2 కదా, that is equal z cube f of z minus u naught minus u1 by z minus u2 by z square. So 3 కాబట్టి up to 2. So similarly up to so on. So remaining finding. This is second shifting theorem. So next one. Initial value theorem. So see the initial value theorem. If z transform of un is equal to f of z, then u naught is equal to limit z tends to infinite f of z. And how to finding the in the sequence terms find out u naught, u1, u2, u3 up to so on. We have to finding the terms of the sequence. So using this formula, this is first initial value theorem. So u naught is equal to limit z tends to infinite f of z means given z transform of given sequence. Okay na? Similarly you have to finding a u1 is equal to limit z tends to infinite z into f of z minus u naught. అంటే u1 ఫైండ్ అవుట్ చేయాలంటే ఫస్ట్ ఆఫ్ ఆల్ u naught ఫైండ్ అవుట్ చేయాలి, మనకు తెలిసి ఉండాలి. ఓకేనా? సో ఫస్ట్ ఫైండింగ్ u naught సబ్స్టిట్యూటింగ్ ఇయర్, నెక్స్ట్ ఫైండింగ్ u1. సో నెక్స్ట్ ఫైండింగ్ u2 how to finding, but first we know that compulsory we find u naught u1, that is equal u2 is equal limit z tends to infinite z square. సో చూడండి z స్క్వేర్ ఇయర్, u1 అంటే z పవర్ 1, u నాట్ అంటే z పవర్ 0. ఓకే, u2 దట్ ఈస్ ఈక్వల్ z స్క్వేర్ ఇంటూ f ఆఫ్ z మైనస్ u నాట్ మైనస్ u1 బై z. సో నెక్స్ట్ u3 ఈజ్ ఈక్వల్ టు సేమ్ లిమిట్ z టెన్స్ టు ఇన్ఫినిట్ z క్యూబ్ ఇంటూ f ఆఫ్ z మైనస్ u నాట్ మైనస్ u1 బై z మైనస్ u2 బై z స్క్వేర్. సో అప్ టు సో ఆన్. సో నెక్స్ట్ ఫైనల్ వాల్యూ థీరం. So final value theorem means, so if z transform of un is equal to f of z, then u infinite, and the last term up to infinite terms we have to finding here, that is final value theorem. So u infinite is equal formula limit z tends to 1 z minus 1 into f of z. Substituting here, now finding the value. So that is u infinite. That means initial and final value means you have to finding the all terms of the sequence. Okay, now. So this is the properties and the theorems. Okay. Yeah, see the first example here. If the z transform of the sequence un is 2z square plus 3z plus 14 by z minus 1 whole cube. Now finding u naught. U naught means using initial value theorem. Okay. So given z transform of un is equal, this is f of z. So by initial value theorem, u naught is equal to limit z tends to infinite f of z. So that is equal to substituting here, limit z tends to infinite f of z is equal to given. So 2z square plus 3z plus 14 by z minus 1 whole cube. So that is equal to limit z tends to infinite. So how to finding at the limit point is infinite. So we have to the common highest power of z in the numerator and the denominator. So that is equal to highest power derivative. Sorry, highest power of z is a common. Numerator is z square common. Denominator z cube common. Okay, na? That is equal to here. Cancellation is 0 because z square by z cube is 1 by z. 1 by z means 1 by infinite. 0. 0 into something 0. So that is equal to u naught is equal to 0. Okay. Yeah, second example here. If z transform of un is equal to 4z square minus z by z cube minus 6z square plus 7z plus 4, find u naught u1. So first given z transform of un is equal, this is f of z. Okay. So by initial value theorem, u naught is equal, the same procedure the previous problem. So limit z tends to infinite, this is a given f of z. Okay, now we have to common highest power of z in the numerator and the denominator. So that is equal to here, numerator z square common, denominator z cube common. So that is equal to z square by z cube means 1 by z. So 1 by infinite is equal to 0. So u naught is equal to 0. Next one u1. u1 is equal formula is limit z tends to infinite z into f of z minus u naught. Okay, na? Substituting f of z substituting and u naught was substituting. So that is equal to limit z tends to infinite z into 4z square minus z by z cube minus 6z square plus 7z plus 4 minus 0. So now simplification, you have to common here z square common and denominator z cube common. That is equal already z into z cube by z cube and cancel. That is equal to substituting here 4 minus 0 by 1 minus 0. That is equal to 4. So this is a required value. u1 is equal to 4. So next one. Yeah, if z transform of un is equal to 4z square minus 2z by z cube minus 5z square plus 8z minus 4, find u infinite. U infinite means final value theorem. Okay, na? So using that formula, so given z transform of un is equal to f of z. Okay. So u infinite is equal to limit z tends to 1 z minus 1 into f of z. So that is equal to here limit z tends to 1 z minus 1 f of z is equal to given substituting. Okay. So directly substituting z is equal 1, that is 0 by 0 getting under. So 0 by 0 is not defined here. So now simplification. So in the denominator is a polynomial. Now separate the factors. That is equal to here factors same as manaki limit z tends to 1 z minus 1 into the numerator 2z common 2z into 2z minus 1. So denominator factors z minus 1 into z minus 2 whole square. Okay, na? So now z minus 1 is the cancel. So now substituting z is equal to 1. So that is equal to here z is equal to 1 substituting, we getting the 2. So this is the u infinite is equal to 2. Okay. So next one, so find Z transform of 1 by n plus 1. So using that formula 1 by n plus 1 means, so directly we can find the by definition or by using the shifting property. ఇక్కడ ఏమని చెప్పండి, un plus 1 అన్న అజంప్షన్ un plus 1. సో ఫస్ట్ we have to find the sequence is un is equal ఏమవుతుంది మనకి 1 by n, అంటే 1 by n n ప్లస్లో n plus 1 కదా, అంటే you have to finding un plus 1. సో un is equal to 1 by n. సో un plus 1 is equal to 1 by n plus 1. Okay, now by using the shifting property, second shifting property. So first of all finding Z transform of un. So Z transform of un ante Z transform of 1 by n is equal to, already finding 1 by n ki Z transform log of z by z minus 1. So that is equal to f of z. So z of un is equal to f of z. So that is equal by using second shifting theorem. What is the formula here? Z transform of un plus 1 is equal to z into f of z minus u naught. So first of all finding u naught value. Okay now, so that is equal, u naught is equal by using initial value theorem. So u naught is equal to limit z tends to infinite f of z. Okay now, substituting f of z, already finding log of z by z minus 1. So directly substituting here, log infinite not defined here. Okay now, so now simplification is limit z tends to infinite log of z common. So that is equal to here z 1 minus 1 by z. So z is a cancel, that is equal to 1 by 1 minus infinite, and 1 by 1 minus 0 means log 1. Log 1 is equal to 0. Okay na, so u naught is equal to 0. From equation 1, z transform of un plus 1 ante 1 by n plus 1. Okay, so that is equal to z into f of z log of z by z minus 1. U naught is equal to 0. So therefore the required value of z of 1 by n plus 1 is equal to z into log z by z minus 1. So this is using the second shifting theorem. Okay, yeah, next example here, this is the important long question. Find z transform of un plus 2. So z transform of un is equal to given z by z minus 1 plus z by z square plus 1. This is already given, z of un is equal to f of z. So by using the second shifting theorem, so z of un is equal, that is f of z. So that is z of un plus 2 is equal formula z square into f of z minus u naught minus u1 by z. Okay, now finding u naught and u1. Okay na, so u naught is equal to initial value theorem. So limit z tends to infinite f of z, that is equal to limit z tends to infinite f of z is equal to given z by z minus 1 plus z by z square plus 1. So take out the common, the lowest highest degree of z. So first term is z common, z is a cancel, 1 by 1 minus 1 by z plus. So second term z common, denominator z square common, that is 1 by 1 by z. So 1 by z into 1 plus z square here. So that is equal to ఏమవుతుంది here, ఇది 1 అవుతుంది, this is a 0 అవుతుంది, 1 by z. So that is equal to u naught is equal to 1. Next u1 is equal to limit z tends to infinite z into f of z minus u naught. So that is equal limit z tends to infinite z into z minus 1 plus z by z square plus 1, u naught is equal to 1. So now simplification ఏం చేసి అంటే by using take the LCM చేయొచ్చు. So after take the LCM we getting the lengthy procedure. So now here simplification is ఇక్కడ 1 ప్లస్ లో, సో ఫస్ట్ z తో మల్టిప్లై చేయండి, z into z square by z minus 1 plus z square by z square plus 1, that is z. So z plus లో dividing and multiply with z minus 1. ఓకేనా, సో ఆఫ్టర్ సింప్లిఫికేషన్ is ఇక్కడ చూడండి మైనస్ z square by z minus 1, ఈ టర్మ్ క్యాన్సిల్ అయిపోతుంది చూడండి ఫస్ట్ టర్మ్. ఓకేనా, సో రిమైనింగ్ ప్లస్ z by z minus 1. సో దట్ ఈస్ ఈక్వల్ టు z square by z square plus 1, remaining term z by z minus 1. So now applying the limits, denominator common, the numerator denominator z square common. So 1 by 1 plus 1 by z square plus z common, second term 1 by 1 minus 1 by z, that is equal, substituting z is equal limit, ఇది ఏమవుతుంది 1 by 1 plus 0 అంటే 1, ఇక్కడ 1 by 1 minus 0 అంటే 1. సో u1 is equal to 2. So now substituting in equation 1. So from equation 1, z transform of un plus 2 is equal to z square into f of z. Is substituting u0 is equal to 1 minus u1 is equal to 2 by z. So this is the required value. Okay. So next one here. Find z transform of 2 into 3 power n plus 5n. Hence deduce z transform of 2 into 3 power n plus 3 plus 5 into n plus 3. Okay, now first of all finding here z transform of un. Next మనకి ఏముంది ఇక్కడ un place లో n place లో how much substituting n plus 3 అంటే this is z transform of un plus 3. Okay na, first finding here let un is equal to 2 into 3 power n plus 5n. So z transform apply, z transform of un is equal to z transform of 2 into 3 power n plus 5n, that is equal z into z transform of 3 power n plus 5 into z transform of n. So that is equal by using the formula a power n kada 2 into z by z minus 3 plus 5 into z transform n is equal to z by z minus 1 whole square. Okay, so next one. So this is the required z transform of un is equal to this is f of z. Okay now, so now using the second shifting theorem, z transform of un plus 3 is equal to formula z cube into f of z minus u0 minus u1 by z minus u2 by z square. So now finding u0, u1, u2. Okay na, so from the given sequence here, so substituting here. Okay na, un plus 3 ante un plus low. Okay, so that is equal u0 is equal to from un kada un is equal to here. Okay, u0 n is equal to 0, substituting here u0 is equal to next n is equal to 1, u1 is equal to 11, next n is equal to 2, u2 is equal to 28. Now substituting all values here, z transform of 2 into 3 power n plus 3 plus 5 into n plus 3 is equal to z cube into a substituting u0, u1, u2, a substituting. Okay na, so this is the required value. Okay, so that is equal to here. So this is a problems on shifting theorems and initial and final value theorem. For more videos please do subscribe my channel, like and share it. Thank you.